Coming to another interesting topic of persistence of vision. Now we know that we are able to see the objects around us because the image of the objects is created on the retina. And we are able to see that object so long as the object is in front of us. Because so long as the object is in front of us, its image remains on retina. But the moment the object is removed, the image also disappears from the retina. But this doesn't happen instantaneously or immediately. The image does not instantly disappear from the retina. It remains on the retina for 1/16th of a second even after the removal of the object. And this sensation of the image being there on the retina for 1/16th of a second is referred to as persistence of vision. We have numerous examples of persistence of vision, like a parrot inside a cage. Now you can draw a parrot on one side and a cage on the other side of a page. And then you need to move it very fast, rotate it. You will find as if the parrot is inside the cage. Now let us understand persistence of vision here. Both parrot and cage are on the opposite side, but it appears as if the parrot is inside the cage. So when the image of parrot comes in front of us, the image is created on the retina. But within no time, the image of cage comes in. Before the image of the parrot disappears from the retina, the image of cage comes in. And this happens within 1/16th of a second. So if another object is brought in within 1/16th of a second, the two get superimposed and the brain interprets as if the parrot is inside the cage. So this is happening very rapidly. Before the parrot disappears, the cage comes in, and before the cage disappears, the parrot comes in. And it appears as if the parrot is inside the cage. In the elephant picture, if you can count the number of legs the elephant has got. So there also we find that before we see one leg, there is another one which becomes visible to us. And this is also an example of persistence of vision. The third picture here, we can see number of different versions of this image if you look closer. Initially only a old woman and a man can be seen, but if you see it minutely, you will see several other images also. So this is what is referred to as persistence of vision. That is, any object that we see, the image of that object remains on the retina for 1/16th of a second. And if another object is brought in, it appears as if both are in continuation. This is very well seen in a movie. When we go to see movie or we see the movies at home, we feel as if the entire 3-hour movie is in continuation, though that movie may have scenes from various places and at various times. Still, it appears as if it is a one continuous movie. Because before the image of one scene disappears, the next comes in, and the third and the fourth. And this is going to happen if there is persistence of vision. So before the first scene disappears, the next comes in, and it appears as if both the scenes are related to one another. So these are some of the examples of persistence of vision. Burning incense stick is another one. You light a incense stick in a dark room and then rotate it very rapidly, making a circle. You will find as if there is a complete circle of light. Rotate the stick very fast. So that entire circle is created due to infinite number of points that are there. But before the image of one point disappears, there is another point that comes in, and the third and the fourth. And it happens so fast, within 1/16th of a second, that an entire circle of light is formed. So there are several such examples of persistence of vision. So carry out these experiments at home. You can always do it for an incense stick and this a parrot inside a cage. You can even select a fish inside a fish pond or aquarium, and several such images can be made, and we can study persistence of vision. Uses of concave lens. We have studied concave lenses. Here is a list of uses where we make concave lenses are used, and you should go through it. At least 4 examples you must remember for a 2-mark question. You must be able to give 4 examples where the concave lenses are used. Let us end the lesson with an interesting activity. The person that you see here is Ferdinand Monoyer, and he was a French ophthalmologist known for introducing the diopter in the year 1872. We know diopter, the power of lens, is expressed in the unit diopter. So he was the one who gave us the Monoyer chart. So here this chart that you see is there in every ophthalmologist's cabin, and the person who has some problem with the vision visits an ophthalmologist. He is going to make the patient read what is written here. All these alphabets he is going to make the person read. So this is called as a Monoyer chart, and what is interesting about this chart is that reading upwards on both ends, ignoring the last line, the name Ferdinand Monoyer can be seen. He invented Monoyer chart used to test the visual acuity. So we can do this. We have to just ignore this last line, that is Z and U, and then we have to start reading from here the last letters in the upward direction, and we can read the name of the inventor, that is Monoyer, and this side again last letters Ferdinand. So with this we come to the end of the lesson. We have completed all the activities and all the topics that were there in the lesson. Read the lesson thoroughly, underline important lines, practice the ray diagrams, and learn the various defects associated with vision, the structure of the human eye, and their functions. In the next class, we will be taking up the question and answers. Thank you.